Hi Year 10, welcome to your introduction videos. This week we're going to learn some descriptive statistics, so like means, medians, modes, range, that kind of thing. And this stuff starts from the very easy to relatively difficult. I taught you this in Year 9 and didn't find it quite as easy as I thought, so we'll see how you get on this time. Okay, so we need to be able to find the mean, median, mode, range of a simple list of data. That's pretty straightforward. We need to be able to find the quartiles, percentiles, and interquartile range of a list of data. And then this week we're gonna look at how we find the mean. The mean, median, and mode actually from a non-group frequency table, but just the mean from a grouped frequency table. And next week it's going to be about finding other statistics from grouped frequency tables. Okay, so that's what we're doing. So here is a simple data set. We've got to calculate the mean, median, mode, range, lower quartile, upper quartile, and interquartile range. Now stop your video and have a go and do the things that you do already know how to do. And then we'll go through it. Okay, so hopefully you've done that. Now, you can do this using a calculator. But actually, you can also use your graphic display calculator to do actually everything for you without doing much work. So there's a separate video where I'm going to show you how to use a calculator to do some of these things as well. So make sure you watch that video too. Okay. Now, whenever you get data like this, we don't know what this data represents, so we can't interpret the information. But what we should always do is, if we've got a simple list of data, let's just put it in order, okay? So first of all, count how many you've got. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bits of data. So let's put those 15 bits in order. So I've got 2, I think 3 threes. I can see 3 threes. How many 4s? I can only see 1. We'll check at the end if I've done any wrong. How many 5s? 1, 2, 3, 4. 4 5s. Okay, and 6s. I think I can see 2. 2 7s. An 8. And a 9. Let's check that's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I think I've done it right. Right, so the mean, hopefully you realise, okay, is equal to adding up all of the values, okay, and then dividing by how many numbers there are, okay. I'm just going to show you a little bit of notation here. Here is the formula. Okay, and what that means is this funny symbol here, this means add together, sigma. Add up. So it's saying add up all the x values. We've said all the bits of data in the set are x values. So add up all your x values, and then divide by n, where n would represent how many numbers there are. Okay, and you could just simply use a calculator. So I'm just doing that now. 2 plus 3 plus 3 plus 3 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7 plus 7 plus 8 plus 9 comes to 78, divided by, there are 15 numbers, so divide that by 15, and I believe that will give you 5.2. So there's your mean. That should be really easy. Once you've got your data in order, the median, one thing before we move on to the mean. Another way of saying the mean, it's just notation, x barred. Okay, if you see that, x barred, what they mean is find the mean. Okay, x barred. So when you're using a graphic display calculator, you need to know x barred is the mean. Okay. Median. Now the median is simply the middle number, isn't it? Okay, you've got 15 bits of data. So what you can do is say, well, what's halfway through? 15 divided by 2 is 7.5. So what we always do really is we round up. So if it's 7.5, so therefore we want the 8th piece of data. The 8th piece of data. Okay, if you think about it, the 8th number is going to be bang in the middle. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. The 8th piece of data. It's right in the middle there. So that's going to be 5. So the median is 5. The middle number is 5. Mode is very, very easy. That's just simply which number appears the most. Again, it's 5 because 5 appears 4 times more than any other number. And the range is also easy. The range is the biggest number minus the smallest number. So 9 minus 2, the range is 7. Okay? Now just in terms of interpretation, the mean, the median, and the mode are what we would call measures of location. They tell us where roughly the middle of the data is. Okay? The range is something different. It doesn't tell me about where the middle of the data is. What the range does, it tells me how spread out the data is. How spread out it is. Is all the data packed in closely together, or is it all far apart? So when you think about data, you always need to consider 2 things. So where is the middle of it, and how spread out is the data? As you progress with your mathematical career, you'll find better ways than the range to measure how spread out a data is. One slight improvement is the interquartile range, okay? But then there's even better ways of doing it. But you don't need to do that IGCSE, that's IB skill, okay? Right, so now that's pretty easy. You should have been able to do all of that on your own. What you may have forgotten is how to find the lower quartile, the upper quartile, and the interquartile range. Now, consider the median. The median is where is the 50th percent value? So where is the value that is halfway through the data? That is to say, half of the data is below that value and half of the data is above it. Well, the lower quartile, hopefully you understand the word quartile, is where is the 25th percent value? Okay, and the upper quartile is where is the 75th percent value. Okay, so basically what the quartiles do is they split the data into quarters. So 25% of the data is below what the lower quartile is and 75% is above it. For the upper quartile, 25% is above it and 75% below it. Okay. So another way of referring to these, the median we can refer to as Q2, lower quartile Q1, and upper quartile Q3. This is basically splitting them into quarters. Now I've just realised I've deleted the data. I wish I hadn't done that. So I'm just going to have to write the data in again in order. Always have to do it in order. So it was 2, 3, 3, 3, 4, so just 1, 4, 1, 2, 3, 4 5s, 1, 2 6s, 2 7s, and 8 and a 9. Let me just check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Right, so what we do is we already did the median, so we knew the median was the 8th value. That's halfway through. 1, 2, 3, 4, 5, 6, 7, 8. It was this value here, so it was 5. Okay. If you want to take the lower quartile, all you do is you take the values that are below the median. Okay. And you look for the median of those values. So here we've got 1, 2, 3, 4, 5, 6, 7 values. So the middle of 7 is going to be the 4th value. 1, 2, 3, 4. So Q1 is going to be equal to 3. 3, because the fourth value is 3. Okay, the fourth value is 3. We're not looking for 4, we're looking for the fourth value. Okay, Q3, whoops, didn't mean to delete that. Q3, we look at the numbers that are above the median, and we count, again, there's 7 of them, so it's looking for the fourth one. 1, 2, 3, 4, that is 7. So Q3 is equal to 7. Now the interquartile range is simply equal to 7 minus 3. Well, that's to say Q3 minus Q1, and so that would be 4. 7 minus 3 is equal to 4. So interquartile range is equal to 4. The range is 7, the interquartile range is 4. So both the range and the interquartile range are measures of how spread out the data is, which is a very, very important thing to know about data. Okay, let's just do it one more time for this data here, because you have to treat it slightly differently. You'll notice with this one, this had an odd number of data points, whereas this one has an even number of data points. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 data sets even. Data points, rather. So we got, let's list them out in order. That's always the first thing you do, put everything in order. 1, I can see 2 2s. I can see a 3. I can see 2 4s. 1, 2 4s. I can see a 5. I can see 2 6s. We'll amend if necessary. I can see 3 7s. 1, 2, 3. Any 8s? Yes, 2 8s it appears. 9s. Yeah, I can see 2 9s. I can see 2 10s. Can't see an 11. Can't see a 12, but I can see a 13. Right, I reckon I probably missed some. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I have missed one. What have I missed? So I've got a 1, 2 2s, let's cross them off, 3, 2 4s, I've got a 5, 2 5s, that's where it was, so let's put another 5 in there. Okay, 2 5s. Okay, so now we're in a position to answer all the questions. So the mean is we add up all the numbers and divide by how many there are. So I'm just going to do that right now. 1 plus 4 plus 3 plus 8 plus 10 plus 12 plus 21 plus 16 plus 18 plus 20. You can see a little way I'm cheating to try and make it quicker. Okay, which is 126 divided by 20 data points is 6.3. Okay, the median. Now this time you've got 20 data points, so you'll be foolish to do this. 20 divided by 2 is equal to 10, so you take the 10th value. Okay, that is not true. Where is the 10th value? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we can split the data in half, and you can see clearly from that there is actually no number that is in the middle. So what we do is we take the 2 middle points and take the average of that. So actually Q2 should be the 10th and 11th. So 6 plus 7 divided by 2 to get the average of that, so it'll be 6.5. Okay, the median is 6.5. If you've got an even number of data points, take the 2 middle numbers and take the average of those. Okay, mode should be easy. Which one has the most? which is 7. 7 appears 3 times. And the range, also easy. Largest number minus smallest number is equal to 12. Okay. Now for Q1, the lower quartile, you're going to basically include the 6 and include the 7 when you split apart. Okay, so basically you're going to try and find the middle of the bottom half and for the lower quartile, and the middle of the top half for the upper quartile. Each half has 10, so you're looking for the 5th and 6th. 1, 2, 3, 4, 5, 6. Notice how the 5th and 6th are both 4. So Q1 is equal to 4. And for the upper quartile, it's 5th and 6th again. 1, 2, 3, 4, 5, 6. Notice this time the 5th and 6th are different numbers, so we take the average of those. 8 plus 9 over 2, which is going to be equal to 8.5. So the interquartile range is going to be 8.5 minus 4, Q3 minus Q1. So the interquartile range is 4.5. Okay, so I hope that makes sense. Let's just delete that for a second. We've got one more little question to do. What you can actually do, you can actually find any position within the data. We could also calculate what is known as the 40th percentile. So 40th percentile, 40%. So the way we label that is we would call that percentile 40. And all we're going to do is we're going to find 40%, so that's 0.4, times the number of numbers, which will be 8. Okay, so we're looking for the 8th number, the 8th data point. Okay, so I just deleted the numbers again. I can't remember exactly what it was, but with that list, we just count to the 8th number. Let's say I think it was 1, 2, 3, 4, 5, 6, 7, 8. It was 5. Okay, so we can find any percentile. You know, if you wanted to find P20, find the 20th percent. So that would be the 4th number, which would be 3. Okay, and you could find the 40th to 20th interpercentile range. That would be P40 minus P20, which would be equal to 2. That would be the 40th to 20th interpercentile range. Might be an interesting statistic to calculate. Okay? Right, so I'm going to stop the video there, and in the next video we're going to